Okay, so today's opener is going to resemble much like what your quiz is going to look like on Friday. You're solving one-step equations with fractions. So let's take a look at the first two. We have r minus 5/9 equals 1/9. When we solve equations, we always circle the variable, we draw our line of equality. The reason why we circle that variable, because that's our visual cue that we want to get that variable by itself. In order to get that variable by itself, we're going to have to do inverse operation. So Nick, what does inverse operation mean? Yeah, in order to get the variable by itself, I'm going to use inverse operation. So what's inverse operation? You can tell me what it is if you can look up here. Yeah, change the sign. So we're going to change that sign from a minus to a addition. So we're going to add 5/9. Now, our golden rule, whatever we do to one side of the line of equality, we must do to the other. So now my variable's by itself, so I'm going to cancel out that on the left. I'm going to bring down my variable r, my equal sign on my line of equality. Now I have 1/9 plus 5/9. Now right here, my denominators are the same. So I don't have to worry about finding a common denominator for this specific problem. So all I need to do is add my numerators. So what's 5 plus 1?
6.
Over the denominator?
9.
Am I finished with this problem?
No.
Why not?
Good, you got to simplify by 3.
Yeah, I can reduce or simplify. 6 and 9, as Darius just said, are both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is
3.
simplest form.
No.
2/3 can be reduced further?
No.
No, so yes, it is simplest form. So I'm going to box that whole entire thing. So r equals 2/3. Now, if you guys just use your calculator to solve, you're just going to have r equals 2/3. You won't have this mental work here, which is fine. But the main things that I'm going to look is that you have variable circled, you have your line of equality, you showed inverse operation, you showed the golden rule, whatever you do to one side, you do to the other, your answer with the box around it. All right, let's take a look at the next one. We have negative 6s equals 15. Anytime a variable is touching a number, what operation does it ask us to do? Multiply. But to get the variable by itself, we do the opposite of multiply, which is divide. So, as he said, anytime a number is touching a variable, it means to multiply. But to get the variable by itself, to solve a one-step equation, we do the inverse operation, which is divide. When I go to divide, what am I going to divide each side by? Negative 6. Way to remember that negative. That negative goes with the number. My 6's cancel on the left. I bring down my variable. Now, are you allowed to have a negative in the denominator?
No.
You just told me no a second ago. Yeah, no, you're not. So all you're going to have to do is move that negative up to the top. There's nothing fancy that you need to do with it. You just move that negative up to the top. So I'm going to go ahead and put my negative in my answer down here. Now, 15 divided by 6, if you divide that out using your calculator, you're going to end up with a decimal. I don't want a decimal. I want it left in fraction form. So 15 over 6, you're going to have to look to see if you can simplify. Well, can you divide or can you simplify 15 over 6?
No.
So 15 and 6 is in simplest form? No, it's not. 15 and 6, divisible by 2? Are they divisible by 2? No. By 3. 15 and 6, they're both divisible by 3. So what's 15 divided by 3? 6 divided by 3?
2.
5 over 2, is that simplest form?
No.
What else can you divide it by? So then that's simplest form. So then your answer would be yes. It's in simplest form. Are you doing inverse operations on us? Okay, so we said the negative we bring up to the top. I went ahead and wrote my negative down below in my answer. So now I just need to put my 5 over 2, and then that's going to be my final answer. Yes?
Okay, I heard that answer, but it was 2 over 5.
So what you did, 2 over 5.
Yeah, we just put the.
How did you get 2 over 5?
Because we typed it, I typed it in calculator.
Do you see what you did?
Yeah, I did.
Okay. All right. Any other questions on the first two? I guarantee you, you will have a question that looks like the second question here on your quiz, right, Deontay? All right. The last two problems. Draw my line. Now, to get the variable by itself, what am I going to have to do here, Brendan? What am I going to do in order to get the variable by itself here? And I must do that to the other side as well. Cancel. Bring down my variable. Now your calculator will do all the work for you, but I want to do it by showing all my work. So I have to find a least common multiple or the common denominator for 4 and 5. Raise your hand if you can tell me what the least common multiple or a common denominator would be. Darius? 20. Nice. So I'm going to come out to the right here. So then I have to find a new numerator. So 4 times what gets me to 20? So then what's my new numerator going to be? Good, because you took 3 times 5. Okay? So then I need a new numerator for my second fraction. 5 times what gets me to 20?
4.
So then what's my new numerator?
8.
Because you took 2 times 4, got me to 8. Now, what operation am I doing?
Subtraction.
Subtraction, because there's my subtraction sign right here. So I'm going to take my numerators and subtract them. So what's 15 minus 8?
7.
The denominator?
20.
Can I simplify or reduce that?
No.
No, you cannot.
Final answer. Nice. Just showing us how smart he is. He's got it today. All right. We'll discuss that later. Okay. Circle our variable. Again, draw our line of equality. Now, if I want to get this variable by itself, what inverse operation do I have to do, Rihanna?
We have to put 4 over 5 on both sides.
So I just put 4 over 5 like this?
No. Wait, no. You
What operation do I have to do?
Oh.
How do I get rid of this 4 out of 4 over 5?
You subtract it.
Well, what's that little dot mean to do?
Oh.
multiply, but you got to do it.
Hold on. What's that little dot mean to do? Ladies and gentlemen,
Matter of fact, he can answer since he knows.
I'm calling on you.
You want to multiply, right?
Okay, so what's the opposite of multiply?
Divide.
Divide. So we're going to divide by 4 over 5. Now, this is where I'm going to use a fraction bar, or the division bar. Now, this is where it's going to be really important that you pay attention to where you write your numbers. Because when you go to divide, this first fraction, the 14 over 15, goes first. This second fraction then goes second. So it's 4 over 15 divided by 4 over 5, okay? So when you type that in your calculator, you type in this first one, 14 over 15, first. I'm going to work it out longhand. So I have 14. So keep, right? What do I flip?
Flip the 4 away.
Yeah. So 5 over 4. I change my division into...
Multiplication.
Okay. Kelsey, from here, can I reduce any of these numerators with any of these denominators? What? Okay, what do they go to? What are they both divisible by? 5 and 15 are both divisible by what? Can somebody raise your hand? Somebody help Kelsey out? Nick?
3.
No. Darius?
It's 5.
5. Yeah, you can take 15 divided by 5 and get 3, but you can't take 5 divided by 3. You can take both of these numbers, 15 and 5, and divide them by 5. Asia, what's 5 divided by 5? 15 divided by 5. 15 divided by 5. Okay? Can I reduce any other numerator with any other denominator? Deontay, thanks for raising your hand. What else can I reduce here? What are they both divisible by? 2. So what's 14 divided by 2, Deontay? 14 divided by 2?
Set.
7. And then 4 divided by 2, Deontay? 2. All right, from here, you multiply your numerators. So, Brendan, what's 7 times 1? Jemiah, what's 3 times 2?
6.
So that is going to be my final answer, 7 over 6. What kind of fraction is this? Anybody? Improper. So when you used your calculator, you ended up with a mixed number. Make sure you hit that second button, the fraction button, and the equal sign to change that mixed number back to an improper fraction. Any questions? All right, go ahead and make sure your names are on and pass them towards Mr. McFarland.